Hi, I'm going to talk about the National City Bank. This customer propensity model that I choose from the three models analyzed. It's really important because the best model predicts better, and from that I pick the top 100 customers, and these top 100 customers are more likely to choose our service. So the objective of this analysis is to get these top 100 customers because it's part of like get the best outcome for our company. So after an analysis, I choose like this decision tree model, and I'm going to explain why. So first, I just picked the data. I got like five CSV files. Three of them were additional data information from our customers. I merged them to one train table and another test table. The train table has 4,000 rows, and the test table one had 1,000 rows. I did some feature engineering. I checked the data with EDA. I selected the target customer if the customer accept the offer was really important. So first, I did in the feature engineering, I did the duration of the call. So I subtracted the end of the call from the start of the call and make it in convert it in seconds. With that, I mentioned this variable because it's really important for my model. It's the one that predicts better the the outcome. So the three models that I used in this were logistic regression, decision tree, and random forest with Ranger. And I selected the model because thinking about the accuracy, which one has the best accuracy and predicts better, and the importance of that's really important for the best model. So I started talking about with like logistic regression. This performed really poor, 19.02% of accuracy. So I didn't use that model at all. I just check it and got like really poor results on it. After that, I did random forest with Ranger. I think this model is better because it's for a lot of dimensions. So you have a lot of dimension. We have more than two variables. You start adding dimensions and these kind of models. So with that, I got 65.94% of the accuracy of this model, and for the validation, a 6486 is way better than it performed way better than the logistic regression. Then I did a decision tree. And for the decision tree, I use the RPART package. This model allow me to visualize on the relationships between variables and create a set of rules for predicting the outcome. The decision tree model achieved a 78, 62% on the training data and 77.99% on the validation data. It provided more consistent accuracy results and fewer rules compared to the other models. That's why I choose this model. Here you can see after choosing the model, these were the top 10 variables that were more important. The best variable for predicting were the feature engineer, the difference in seconds of the call, and then variables like related to the contact with the client, like if we contacted the client before, how many times, if the previous month we contact them, how many attempts, and things like that were really important for the model. So I did some things for for getting the top 100 after ending up with this model. I paste them the top 100 in a Word with a further explanation of what I did. I also commented the R script for with the models and everything I did on it, so you can have like a better understanding of what I did. I did some analysis like this, some graphs in their code. That is that graph the probability of the of when they accept and they did not accept. So in the EDA, so we can like check, have more understanding what we got. So then the decision tree was the best, the one that performed the best. This graph I did it in the R after analyzing it. So once we have like the best model and the top 100 customers for the bank, then we can focus on these variables that were important, so we can target in marketing for the customers and get them to buy the loans because they are the more likely to buy the loans. It will improve our profits. Yeah. For experiment and feature engineer could be necessary in the future, but I think so far I got like really good results. I think that one of the most important things, apart from the scores that I get, is that I analyze each of the variables and in the code and check what were the most important for us. So in the end, it's not just like writing the code and check it. It's like checking everything, cleaning it, treating the data so it's suitable for doing it. Because if you don't check the data first, you can get some results that are not meaningful. So yeah, thank you. A further and in-depth analysis is in the code because the code is commented and in the word that I'm submitting to. Thanks.